Hi everyone, thanks for joining. I think we're going to start now. Thank you very much. Hi everybody, welcome to today's Somalis in Tech Data and Machine Learning panel. My name is Mariam and I am a customer success manager for a native DevOps solution called Dhawaada. I have been working in the non-technical space for the last 4 years now. Most recently, I have been volunteering my time here with the Somalis in Tech community, helping to bring you guys events. I'm very excited to be hosting today and more excited to be welcoming you all to this event. If you want to join the conversation over on Twitter, please use the hashtag Somalis in Tech so we can follow along. So for those of you who may be new to Somalis in Tech, we are a global organization committed to supporting the upskilling of our community and increasing their presence at all levels across tech. We understand that getting into tech without a support system is hard, and once you are in tech, a network of peers is key to growth and fulfillment. That's why we are here. We are a community to support your efforts and help you out wherever you are in your tech journey. So what do we do? Our mission is to grow the Somali tech ecosystem by providing everyone the opportunity to benefit from tech. Therefore, we hope to deliver knowledge sharing events, hackathons, mentoring, monthly newsletters, and recruitment initiatives, as well as many more activities with the help of the community. As you can see, these are just some of the places our members work at. So the famous last words are, your network is your net worth. I would highly recommend and encourage everyone to utilize the community as much as you can. If you would like to know more about us, our organization, you can visit our website where you can stay up to date with all things tech, culture, and community. Before we get underway, I wanted to do a bit of technical housekeeping. You are more than welcome to have your videos on throughout the event. We have a shared link in the chat to Slido. There you can submit your questions for our speakers throughout, and we'll be answering them at the end of the presentations. These are our panelists today, Ahmed, Alessia, Tosi, and Usama, Ahmed. Thank you all for being here, and we're so excited to have you here today. So without further ado, I'll hand over to our first speaker, Maxamed.
One second. Can you all hear me? Can you see the slides?
Yes, we can.
Hello all. I'm Maxamed. First of all, I'd like to thank Somalis in Tech for organizing this event and for inviting me, and to congratulate them on the wonderful work that they do in running the community. It's absolutely amazing to see what's being done and how it's being done and how energetic and involved people are. When I came up a decade and a half ago, none of this existed, and I know I could have benefited from it massively. So to get started, a little bit about myself. I'm Ahmed. I'm a researcher at Microsoft Research, and I work in machine learning and data sciences. So why data science? Fundamentally, at the moment, an opportunity exists, and I think the most succinct way to capture that opportunity is to sort of look at the opportunities it itself is creating. And if you look around, and these are some slightly older statistics, what you see is something around the top 3 emerging jobs in the next decade will be around data. Yeah, so randomly, I think they've picked artificial intelligence, robotics, and data science, but really it's not the title itself, but what it represents. These are jobs where data plays a critical role in fulfilling the mission and building something. I said I was a researcher, so I'll introduce myself a little bit. What do I do as a researcher? My background is what's called machine learning, and machine learning is the process of building algorithms and methods that allow a computer or a system to learn from experience. Yeah. I'm interested in a couple of projects at the moment, or a couple of themes of work. I'm interested in healthcare, primarily around equity in healthcare, and I'm interested in questions around how do we make healthcare more accessible to more people. Yeah. I'm also interested in language. and questions around how we make language processing more available to more languages, especially for languages that are under-supported and neglected, principally African languages. I've previously used machine learning to do a lot of things. In my previous job, I was using machine learning to make drugs, so to predict what's the next molecule to make, and to say something about what the properties of that molecule will be before it gets tested, for example. I've used machine learning to extract knowledge from data, from papers, from connections, from networks. I've used it to predict people's behavior. I've used it to make physical networks smarter. I've used it to fly drones, to control cockroaches, to have robots to play football, to play music, to learn to play music, and a whole bunch of other things. What that should tell you is that I work in very interdisciplinary teams. Everybody brings their own expertise to a team in order to make that team do a better job, to be able to get that team to attack a bigger problem. Day to day, I write software, I write papers, I manage people, and I speak to a lot of people. And I think most important than that all is the talking to people, because talking to people is where I learn what matters and what doesn't, and what I should concentrate on. Before we begin, I'd like to pose a question for the people on Slack and the people in this call, which is, what is data? Let's have 15 seconds. Could I get any answers on that question? What are people's opinions of what is data? Feel free to say anything you like. Do we have any answers? Information, data is information being passed. Logical collections of information. Okay, interesting. Facts about an object. I think that's the closest thing to it, facts about an object. Information signifies that there's value in it, that you've extracted something with value. Data doesn't have any value. It's what you do with it that ends up having value. Data is effectively observations and facts and statistics we collect about things. So what do I observe? That's the data. And we're constantly gathering data. We're kind of doing data from our surroundings. Let's take a prosaic setup. Right now, you're reading the words I've written there, or the characters I've written there, and you're turning them into words. That's the extraction of data from the screen, and then turning that into some information by turning them into words. So given that, what is data science? Okay, let's throw that out again. Please feel free to say what you think. I'll go and I'll answer myself while we think about it. Okay. Manipulating data to get a better understanding. Science and learning how to get, yes, all of those things. Effectively, data science is what you do with the data. It's the going from the individual observations to the information and the knowledge. It's a process of extracting something that's useful from those observations so that you can do something with it. And data science is the tool and the mechanisms and the methods that allow you to do that extraction so that you can take these observations and you can do something with them. Now, I think the important thing so far in what I've said is that I've not said anything about what this is applied to. I've said things, and it's principally that. What a thing is doesn't really matter. Data science is applied to anything and everything. Everything is data, from everything that you see, you do, touch, interact with. Those are all observations. So data science can be applied to anything and absolutely everything where we're interested in effectively making a decision with our observations. And that's an important thing to remember, because it means that everything is open to data science. And the example that I chose to give here was that, we've all just turned all the words that we've read and we've turned them into concepts. Congratulations, we're all now data scientists because we've gathered some sets of information from what I've written. We've linked up all that information and we've turned it into concepts and knowledge in our heads. And in fact, we've done the data science job. Just turns out that our brains are much, much more efficient and capable than what we can do with computers. So in effect, what we're trying to replicate is that process of gathering information, gathering observations, turning it into information, and turning that into information into something we can do something with. And that's the fundamentals of data science. Yeah. And if we sort of dig in a little bit deeper, we can kind of talk about three things, which are observations, knowledge, and actionable insights. The goal of observations is allow you to gather samples. So samples are what we call the individual things that you see in store, in order to be able to answer something. And when you're talking about gathering, you've got to start to think about, what am I gathering for? How many things do I need to gather? Where do I collect them from? Yeah, who am I gathering them for? What constraints are those things under? Yeah. So observations and the process of gathering observations is the process of thinking about, how do I get the things that actually make sense for the questions that I want to answer? Yeah. Now, the goal of knowledge is to turn those samples, so those observations that we gathered, into something that we understand, that information that we can do something with. Yeah. And this is one of the most interesting components, because this is the analysis part. Yeah. All of these three stages are equally important, and this is the analysis aspect. Yeah. And in fact, what you're interested in here is, how are we going to answer something? Yeah. We're interested in understanding how are we going to answer something. We need to come up with a hypothesis. How are we interested in understanding? I think I should rephrase that sentence. Yeah. We need to come up with a hypothesis. We need to say something about what we're interested in. I expect this thing to happen because of X, Y, and Z. Yeah. We need to come up with a way to test the hypothesis. So how do I know that what I expect to happen has happened? Yeah. And the last and most important thing is that we need to find a way to test what we find. Yeah. Suppose that I make a hypothesis that the world is flat and I gather data from it. Yeah. How do I test that what I found is actually true or not? Yeah. So knowledge is the process of putting together what you're interested in, what you can test, the assumptions that you make about it, in order to be able to come up with something that you can trust. Yeah. Finally, it's the insights that we act upon. Yeah. This is about how we take knowledge to actions that we can actually do something with. Yeah. So we're interested in, how do we interpret the result? I've collected my data. I built a hypothesis. I built something that sort of explains or proves or disproves my hypothesis. So I've turned that data into some knowledge. Yeah. Now I need to interpret it. And this is the process of going from rows of numbers to figures to illustrations to explanations to reports. How do we interpret them? The next most important thing, and I think it's equally it's equally important, is how do we communicate them? This is a problem I often face. As an expert in one domain, you're often having to interact with experts and lay people in other domains. Yeah, but the things that you've learned are interesting for them and useful for them. So how do you communicate that? And that's a very important thing, because if you can't communicate what you found, people can't get value from it. Yeah. And then how do we act upon it? So, I found the most amazing thing in the world. How do I act upon it? How can I actually use it in order to be able to do something with it? Yeah. That's a thing that you've got to consider when you're actually thinking about, how do I take action with data? And then lastly, what happens when things change? The world changes, the observations that you gather change, the constraints that you work under change. So how do we update our hypothesis, our samples, our understanding based on these changes? So how do we move with the changes that we're observing? Now, data is everywhere. And there are many, many, many terms that we're currently using for data. We have everything from big data to ethical data to infinite data to noisy and imbalanced data sets. All of these things are about the state that we observe data in, the state that the world is in as we observe it. Yeah. And these are the kind of things that we work with. Yeah. And it's important at this point to say, all of these things are actually meaningless as concepts when you simply understand them as observations with which you can do something with, and the state that those observations come in. Okay? And the important thing is to understand, what am I going to do with that data? How do I get it? How do I use it? And how do I act upon it? Now, I thought about it a little bit as to what it means to be a data scientist. And what I hope is clear so far is that there's no special field for data science. Data science is anywhere in which you can use observations to make a decision. So an important thing then is to be curious. Because fundamentally what you're interested in is using your curiosity, your creativity and technical depth in order to get answers. So the more curious you are, the more poking you are at the world around you, the better advantage you have. Learning is growth. Right? Technologies change, problems change, job titles change, constraints that you're under change, but still it's growth. We're constantly seeing advances in how we process data, what we use for engineering, what we use for analysis, how we interpret it. All of these things are tools and methods that are constantly coming up. And to be successful, you've got to be willing to grow. You've got to be willing to learn. And that takes me to my last point, which is learning to learn is more important than learning the answer. Fundamentally, this is the thing that we can't do with machines. It's an interesting problem. How do you learn to learn? This is what our brain is built for. We're not built to be able to just answer questions. We're built to adapt. We're built to learn and grow with new input. So the most important skill you can have out of all of this is learning to learn, being open to questions, being open to answers, and being open to growth. Practically, it's important to prioritize the fundamentals. For all the whiz bang and lights, data science is effectively engineering with some stats and beautiful graphics thrown in that order. If you're a practical applied data scientist, you'll be spending a lot of your time hacking through heaps of code and data in order to be able to get to the observations that make sense to you and debugging through it. So it's good to get your fundamentals right in the engineering. It gives you the advantage. If you can't do that, you can't then use your skills to be able to answer the question. The next thing is the maths and the statistics. These are the tools. And in Kenya, they have a term fundi, which is a technician. You're effectively, these are the tools as a technician that you use in order to be able to manipulate that data in order to get an answer. So those are the most important things that you need to get right. The next thing is not to be naive with data. You must always question data. Then being able to make observations doesn't mean that those observations are true. So you must be honest with yourself as to the limitations of your data, what you can say with it, what you can answer with it, and all the caveats associated with it. And we see a lot of that at the moment, everything from how we use data to the ethical considerations of data. People assume just because you have data that you can pass it on to make a decision, and that decision will necessarily be right because it was based on data. That's not true. The data itself could be the problem. So you must always question the value of the data that you're using. And most importantly, what I want to leave you guys with is that anybody that's interested can work in data science. There are no special skills required besides the willingness to learn. So if you're interested, just go for it. All you need to do is open yourself up to learning. And diversity is a strength here. People coming from different backgrounds with different ways of thinking, with different approaches to problems are an advantage for any worthwhile data science team, because what they do is they bring heterogeneity into how that problem is attacked. They bring diversity and creativity to how a problem is tackled. So data science is open to anybody from any background that is willing to learn, and people that are coming from backgrounds outside of the normal STEM subjects often have an advantage in bringing an extra creativity into the job. Finally, I'll put some interesting links into here, of which I think Kaggle is the most interesting, because that's a competition site. Data put up by organizations with questions, and people compete in order to write analysis and machine learning algorithms and so forth on top. And it's a wonderful place to learn, to pick up ideas and to practice your skills. So I highly encourage people interested in data science to play with it. And on that note, I'd like to thank you all for listening and looking forward to chatting with you. I'll pass on to Alessia.
Thanks, Mohammed. I'll try to connect my screen. I hope you can see my screen.
Yes.
Awesome. Thanks very much. And thanks very much for having me actually and invite me to join your beautiful community tonight. I'm Alessia Tosi. I work as a data scientist at the UK government digital service. As you might imagine, I was not born a data scientist. So I thought to briefly actually talk about my journey into data science and which steps have worked for me in the hope that can be helpful to you as well. And I'm quite lucky actually because Mohammed covered a lot of the fundamentals before me, so I can actually skip on those. So my background is in logic and philosophy of language, philosophy of science, and later cognitive science, where I did research on language processing and interaction. So basically modeling how people's speech adapt to each other. So there was a lot of experimental design, what in tech is known as multivariate or A/B test, and then statistical modeling of human-to-human conversations. But if I have to summarize it, I think my interest really is back then and now in experimentation and at the intersection between data, especially language data, and understanding human and their behavior. And I wanted to do something actually at this intersection. And this is what led me, I think, to a career in data science. After my PhD, I joined what in the UK is known as a fast stream. So it's a program actually that moves you around different departments, in my case, in different analytical roles. And that was something really helpful for me because I didn't really know what I wanted to do. I didn't have clear where my place in the world was. And so really this gave me an exposure to different analytical problem spaces and domain areas and ways of working. So I encourage you actually, if you have the opportunity actually to be on a program where actually you're moved around actually to seize that opportunity, especially if you, as me back then, were a bit doubting about, I'm not sure. And then after that, I joined GDS as a data scientist. And you can see actually the first 3 points, actually, there's not a straight line. That's because actually it was not a linear journey for me, actually. I tried a few things along the way before I get where I'm now. And here I try to summarize the journey of some of my colleagues. Of course, I don't know the hidden actually, the hidden journeys. And there are more colleagues actually are not here. But as you can see, actually, they all came from different routes. And only very recently, actually, I started seeing people with masters in data science, actually, but it's not very common, or it not used to be very common, at least until a few years ago. But perhaps if I had to highlight the commonalities at the start of our journey, it's just an analytical mind, curiosity, that was also mentioned by Mohammed, and also willingness to get stuck in problems and not a fear of get stuck in problems. So, but, heterogeneous backgrounds, there is not one way to end up in data science. So what do I do as a data scientist? Well, first of all, I work as part of an interdisciplinary team. And here are a few of us, actually, a few months ago. Some of these people actually have left and some new faces have joined. But we are data scientists, interaction and service designers, user researchers, developers, product and delivery manager. And so it's actually really constantly learning from colleagues with a diverse range of skills and experiences. And this also means that on a daily basis, we are encouraged to share ideas, brainstorm around problems and solutions together and experiment, and also translate actually what we think to different languages actually, so that everyone actually can take part in this conversation and contribute. So maybe something that is not the first skills actually that maybe comes to mind when we think about data scientists, but working collaboratively definitely is a key skill. And learning from others and share your knowledge actually and steer through experience. And if I had to summarize in a nutshell what we do, I think we structure unstructured problems and then we develop analytical solutions. And sometimes this solution actually, maybe I should actually rephrase that. Sometimes actually you realize that the solution is not a data science solution. Actually, and that's also the role of the data scientists, actually understand whether the problem actually is not really a data science solution. And next, I thought to give you a flavor actually of the type of problems and projects actually I've worked on and the technique I've been using. So as I said, I work for the UK Government Digital Service, which exists to make interacting with government better for citizens and to make government more efficient and user-focused by using digital tools. And one of the product we have is Gov.uk, which is a UK public sector information website. It's a huge website with something like 600,000 pages, and where people access all sorts of government information and services. And this is just a snapshot of how users navigate one service on that site. So you can see it's quite dense, complex, and definitely not linear. So on a project, actually, we worked to infer user intent, so user needs actually from this labyrinth of click streams. And what we used was just a combination of smart users, old good matrix algebra, and then some natural language processing, so some topic modeling technique for clustering this journey, actually summarizing the intent. So there was also a lot of data engineering involved in this. Another project I worked on was on recommending actually relevant content on the site. And actually the original approach was developed previously by the team, and I just tested on an improvement on the algorithm that generates the recommended links. So this is not node to back. So this is also something that you end up doing actually, right? So you work on a code base that's been developed by others. Actually, you try to maybe improve the performance of something, and you hope actually that the people before you actually documented and annotated their work. And it's not always the case. So there's a lot of, probably a background in archaeology actually will also quite helpful actually, because you need to make sense of things that have not been documented. So in this case, Node2Back is a machine learning algorithm that learns network node embeddings, and the nodes pages in the same on site, and the edges are how users actually move across these pages, and then the structure, also the connection between the pages. And then we also have a knowledge graph, so I also contributed to building this knowledge graph, or enriching modern building. And so this is really an experimental graph database of all things government. And it's quite fun actually to work with graph databases. And also here again, lots of data engineering involved. And finally, more recently, I joined the effort in working on our named entity recognition model. So we are building a model to detect gov speech language, so keywords and entities that are important to public sector government. And we are here fine-tuning a transformer model, like BERT. You may have heard of BERT, Google BERT, using an in-house label dataset. Hope that gave you a flavor, a bit of the kind of project you may end up working on in data science. These are some of the tools I work with, and let me tell you, I'm not an expert on all of them. I just started learning Docker and AWS first, and it's definitely have room for improvement, right? So, but we have a dev in the team, and that's, I think, why he's there. So don't think actually that you need to master all these tools or others actually perfectly before even starting your career in data science. So how to succeed as a data scientist? I'm not sure I have an answer here, but I share a few thoughts. I'm sure you're familiar with this data science Venn diagram. I think it's been around for ages, actually, where computer science meets maths and stats and meets domain knowledge. And then there, the perfect spot is where the data scientist is supposed to live. And I always find it rather daunting, actually, because I always felt with a feeling, well, I'm not good enough to work in this field, right? So And mine, so these are important building blocks actually of data science, but as individual data scientists, we are not unicorns, right? So I think this diagram is more reflective of a data science team or a data team rather than, an individual data scientist. So you don't need to be an expert at everything, but definitely you'll be willing to learn, as Mohammed also said, and challenge yourself technically and intellectually. I much more prefer this image. And this is something actually I learned through working as applied data scientist. There is much more to the role than the previous diagram suggest. It's really working on projects that you find meaningful and have a positive impact on the world, on people. Actually, whatever the positive impact means to you, is supporting others to grow and learn from others. In the end, I think I said it several times already. This science is a team sport. And it's thinking out of the box, keeping an open mind and not being afraid to question and experiment. And failing is likely to be part of the process. And so finding an organization actually that support that. Said that, how do you get to data science, or how do you well in data science? So there are many guidelines actually on the kind of skills that you have to develop to become a data science and progress actually in the field. So this is just one of them. It's an overview that was produced by the Government Analysis Group. And I like this overview not to feel bad about myself, actually, because of the things that I'm not yet, an expert in, or I will never be, but just really as a helpful guide to steer my learning, to guide my learning, right? So, and plan my development. So identify, where maybe I should focus a bit more actually and learn a bit more, right? So maybe ethics and privacy rather than, data engineering manipulation. So use them as a guide actually on, for your learning. And then a few final maybe tips for me. Do your research, right? So research what companies and organizations work on, right? So many blog about it and find what you like. Find out more about the many roles in data science, and go beyond the title, right? So see actually what the role actually responsibilities are. Learn how to learn. I know that Mohammed said that, and I'm going to repeat it, I think 3 more times, if not 100. Master the fundamentals before actually getting worried about learning the new fancy shiny neural network. Remember that no one expects you to be a unicorn, and if they do, run and talk to people. And that's me. I'm also looking forward actually to the discussion and your questions. And I pass to Ahmed. Go back to Mariam.
Yes, Usama, you're up next.
Yes, I just got an issue where apparently my browser is not letting me share my screen, so I'll see if I can get around that.
Okay, no worries. If you want, I can share for you and just tell
Sure,
me.
sounds good. That would be great. Thank you.
Okay, I'll do that. Give me a second. Share. Okay, let's do that. Okay, great. You're up next. Go ahead.
Cool. All right. Hey, everyone. My name is Usama, and I'll briefly talk about my journey on the next slide. But for now, I figured since you've heard a ton about data science, we should just jump in and talk about data engineering beforehand. So data engineering, at least to me, after working as a data engineer for a couple of years, to this day, is still a field that doesn't get as much attention as data science, and there are some reasons for that we'll talk about. But it's still critical. It's really important because data engineers are ultimately the ones delivering the data that data scientists, machine learning engineers, and others are then going to use to make business decisions, or at least communicate business decisions to the stakeholders that make them: executives, directors, managers, so on and so forth. At a high level, there's a lot that goes on behind the scenes to make this possible. And when everything goes well, it's kind of like a magic trick. So you're not even going to notice anything. And this is why it's super important as a data engineer to be part of an organization that understands the value of data and puts you in a position to succeed. Without that, it becomes pretty difficult because you may not be the one who is, providing the report or that key insight to the big boss in his corner office. Cool. So walking through some of the key things that a data engineer may touch, you have building data infra, designing data models, which is what I spend most of my time doing actually here at Netflix. And then lastly, you have collaborating with data scientists. It's really important. This is all about communication. At the end of the day, it's a team. It's really a team effort. Extracting value out of data is not something done by one function. And then, of course, you have ETL pipelines, super important. It's the bread and butter of a data engineer. So data engineering is a really new field. And because it's a new field, there are a lot of new changes happening, new tools being used, and companies popping up with new things that they recommend data engineers try. But the key tools have remained pretty consistent. You have your Airflow, Python, SQL, Spark. Those are really the four key things that I think a data engineer needs to be really familiar with, and we'll talk about that later. Cool. So my journey to data engineering. I'm from Toronto. I went to school at the University of Waterloo, where I did a degree in management engineering. Management engineering is really all about finding ways to make businesses more efficient. It's traditionally called industrial engineering, but I mean, back in the day, that was all about assembly lines and factories, and we're just not in that era right now. So it's all about how do you take those principles and apply them to more modern companies. I went into this degree thinking that I'd be a consultant. I wasn't really sure what I wanted to do. And after doing a couple internships, I landed into data science. For me, data science was, the cool new thing, the cool shiny thing that people were talking about. And I just wanted to see what it was like. And after doing that internship, I realized that I was spending the majority of my time there building pipelines. So I was like, oh, wait, that means I need to be a data engineer. And so that's kind of where my journey into data engineering started. I mean, I've done a few stints at a couple of different companies. By the way, this isn't something that I would say is super common, because traditionally people become data engineers after spending some time in an analyst role or in a software engineering role. It doesn't have to be that way, but this is at least a good example to show you that if data engineering is really what you'd like to do, you really don't have to wait. You can jump in right away. Cool. So of course, towards the end, if anyone has questions about what these companies were like and how they were different, happy to explain. Like I said earlier, because data engineering is such a new field, every company does it differently. There are some similarities, of course, but even my work on a day-to-day basis has been pretty different from company to company. In my first role at Facebook, I was closer to a data scientist where I was, delivering business recommendations. And now I focus more on building data models, and others pick up the data model and use it to make recommendations. Okay, great. So this right here, this really big figure that you're seeing, I know there's a lot here. It's slightly out of date, but I think it does a pretty good job of capturing what technologies are relevant at Netflix and how the data flows throughout the entire company. So at a high level, you have your hundreds of millions of subscribers watching things every second, and we capture those events, right? And when I say capture events, I'm talking about hundreds of billions of events per day. It's a lot of data. All of this gets loaded into our data warehouse. And this is where a data engineer will spend most of their time. As a data engineer, your key role is to sit in between the software engineers who are pulling in the raw data and the business people, the directors, the executives, the data scientists, the people who are looking to make decisions using data. So that's kind of what makes data engineering fun to me. It's the fact that you really need to have a strong grasp of how the business works, and your product sense needs to be on point. But then in addition to that, you want your programming skills to be there And you also want to be someone who can think ahead, right? As a data engineer, you're automating pipelines. So you want to think about how the data can be used tomorrow and next month and the year after. That way your company just operates in a smoother and more efficient way. So once you're so data storage is a really big thing. I won't be able to do it justice over the course of a few slides, but I'm happy to answer any questions there. Once you build out your pipeline, then what happens is you need to think about how the data is going to be surfaced. One of the most common ways data gets surfaced is, of course, through reports and dashboards, but you can also have notebooks for the more tech-savvy data scientists, or you may even have machine learning models that your data is plugging into. The most obvious example here at Netflix would be the fact that we have a recommendation engine recommending new pieces of content to users. Okay, cool. So data engineering personas. I get a lot of questions about data engineering, and there's a lot of misconceptions people have about data engineering. Well, first of all, before you can have misconceptions, sometimes people don't even understand what data engineering is. Some people think that data engineering is like a hardcore software engineering role, and it absolutely can be. It sometimes is. But there are other types of data engineers who are more business focused, more business savvy, who are thinking more about, once you have the clean data, how do we want to optimize usage of this data? How do we want to connect different data sets within the company? For example, I work within the studio at Netflix. I may be thinking about how I want my data sets to connect better to the teams that are working on, content prediction. What type of content do we need next year? So on and so forth. So there are, in my mind, two different types of data engineers. The more technical ones who are focused on building new infrastructure and tools across the team, org, whatever it may be. And then on the other hand, you have your more business-focused data engineers who are probably collaborating closely with data scientists and product managers who are just thinking about how the business should use the data. This is one of the things I really like about data engineering. I feel like it kind of has room for different personality types. For me, I'm the type of person who likes to, write reports. I like to communicate the value of data to the people who I anticipate will use the data. There's a lot of communication that happens in my role day to day. And I like that. I feel like that's great. I feel like there's a misconception sometimes that as a data engineer, you have to be staring at your screen, throughout the day, when that doesn't have to be the case. So it's nice. Just to summarize, in my day-to-day, like I said on the slide, I may be speaking to stakeholders to understand their needs. Right now, I'm starting a new project that involves building like a new data model for like productions at Netflix, right? And so I need to understand what it is that they're trying to ask. And as a data engineer, I can't immediately take each question that they have at face value. It's on me to dig in, understand if this makes sense from a business point of view, and help them flesh out their questions. And then, of course, there's going to be time to build data pipelines. Like I said earlier, Airflow is a super, popular tool that gets used for data pipelines across the industry. And companies like Netflix that have resources to spare are sometimes going to build their own internal in-house tools that basically, help a data engineer do their job, either by scheduling pipelines, workflows, so on and so forth. Thirdly, designing data models. This is my personal favorite part of the job. I really like designing data models because it's my chance to think about what people need out of the data, right? Depending on the questions that people are asking about my data, I may choose to design my data differently, right? You can aggregate your data, you can normalize it, denormalize it, you can present it in different areas. You can think about how the data should be delivered. Should it be through an API? Should it be through a report? So on and so forth. So that's fun for me. And then the last part is the brainstorming and planning piece. I think this is not unique to data engineering. It happens everywhere, but it definitely takes up a good amount of my time. Okay, cool. So I also wanted to highlight that you've heard about data science, you've heard about data engineering now. There's actually a lot of different roles out there, and there's really something for everyone when it comes to data. Every company is going to be different in how they structure their organization. So this is just how Netflix does it. Other companies may name things differently, but the core idea remains, and the work ultimately gets done, right? You may have a company where a data scientist is doing data engineering work. Not ideal, but it definitely happens. So there's examples of cases where roles may not be what you think they are. Over here, I would say out of these titles, the people that I work with and collaborate with the closest are probably analytics engineers and product managers, software engineers. Those three, we work together on a day-to-day basis. And the rest, I don't. But I also have other people around me that do collaborate with them. So it really depends on the project that you're working on as a data engineer. Okay, so things I wish I knew when I got started. The first thing is you definitely don't want to let hype distract you. Because, as we said earlier, it's a new space, it's moving pretty fast. There are new developments all the time, and no one can really keep up with it as a full-time job. You can try, but it's hard. You don't want to let hype distract you. And when I'm talking about hype, I'm talking about all the different frameworks that are coming up, right? You may have a job that you're really interested in doing, and they're asking for that framework. Instead, I'd really recommend that you focus on the things that are going to persist, right? The foundational skills. If you're really good with Python, if you're really good with SQL, Spark, if you are really good with, I didn't add this here, but I should have, if you're really good with thinking about, if you can look at a piece of data and think about, hey, what are all the business questions I could ask to use this data? If you have that type of mindset, you're going to go very far, because these are the types of skills that you need in every role, regardless of what hot new framework they're talking about. The second thing is, and I fell into this a lot, especially in my first job at Facebook, because I was dealing with lots of different data scientists and product managers. You don't want to say yes to every data request. It's easy to do it because, especially when you're junior and everyone has this like slick way to present what they're thinking about, it may sound like it makes sense, but you really want to dig in. The reason you want to dig in is because it's all about your satisfaction. If you're jumping from question to question to question, it's hard for you to actually deliver anything valuable. So don't say yes to every data request. Think about whether it makes sense. Bring it to your manager, and your manager, if they're doing a great job, they should help you filter things out. The third thing is communicate your work. Again, you don't want to spend weeks and months building something really awesome and then move on to the next thing, because with data, it's really only valuable if someone else is using it, if it's being used to make business decisions, if it impacts the business in a good way, right? So communicate your work, dedicate a lot of time to this, whether that means writing documentation, whether that means making a big post in your Slack, in some of your Slack channels. It's really up to you, and it really depends on how your team operates. But make sure that you carve out time to communicate your work, because this is something that will also take you pretty far. The last thing is definitely do interviews frequently. You want to do interviews frequently because every company does data differently, and every company values data people differently. So staying at, especially early on in your career, I wouldn't recommend staying at the same place too long. You want to get out there and you want to see what's out there. I do get questions about whether it makes sense to depth versus breadth, whether it makes sense to commit to a certain area long-term. I think that's a personality thing. It really depends on the balance you want to strike. As you can probably tell from my slides, I definitely valued breadth over depth early on, and I think it worked out pretty well. Cool, that's about it. If you have any questions about how data engineering is different than software engineering, or how it's different compared to data science, or any other questions like that, please feel free to ask, and I can go over that.
Thank you so much, Usama. And your recommendations as well are here. So everyone who's interested in data engineering, we will make sure we share these recommendations with you. Before we get into questions with Slido, I was going to ask the panelists if they have any questions for each other. You guys are doing great work, and it'll be interesting to know if you guys have any questions for each other before we move on to the viewers today.
Sure, I can go first. I'm wondering if any of you work with data engineers, and if so, how does that work so far, and how do you like that collaboration?
Should I go first? Yes and no. I think it's quite interesting what you said about roles being defined fairly recently. I think if you jump back a decade ago, most people that were working with data were doing a lot of those roles, needing to do that because that specialism didn't exist. That segregation of roles is bringing a lot more expertise, which is simplifying how things get done, and it's making people more productive because there are people that are willing to go to the depth to understand all the details in order to make different roles work. So I personally find it helpful to have people that are building expertise in certain aspects of the data pipeline.
It's the same for me, yes and no. I think where I am now, actually, we just started to have officially data engineers. And I think before is when something that also you mentioned, you have data scientists actually do, I won't say bad, but not the best possible data engineering, right? Because it's needed actually. And, but of course, that's not your strength. So that's happened quite a lot. And also I always like to say it depends also how big the company is. Actually, I think in small startup realities, you need to wear many hats, actually, so you don't have the luxury actually of different professionals, collaborating with each other, each actually focused on one aspect of the project, the pipeline. But yes, I also find it beneficial actually, especially if there is communication actually, so between those that engineer the pipeline and those that use then the output data actually to see, make sure actually that the end of the pipeline is suitable actually for what comes afterwards.
Great, thank you so much, Alessia, for that, and Maxamed. Do you guys have any other questions you would like to ask before we go to Slido? I know the viewers have asked us lots of questions and you guys questions. So more
question. I know that Ahmed actually mentioned his last slide actually things that I wish I knew actually before exactly. So I would like to ask you that question, Mohammed.
Things that I wish I knew before. You don't have to be an expert in everything. That's a big one. I think the other one is failure is a win if you learn from it early on, especially when you're doing investigative work where you're trying to understand things, and what that allows you to do is to be comfortable. Okay, let me step back. I think often when you're working with data, you're working in the dark, meaning you are often trying to answer questions or develop pipelines and processes where there aren't necessarily well-structured sort of templates that you can follow. And recognizing that it won't always succeed, and that if you're willing to take that process as a learning experience and use it to grow, then it can be advantageous. I think that's a big one for me. I think early on, a lot of people assume you must get everything right and everything must work, but that's never the case. So don't be disheartened too easily. What about you?
Yeah, I think I agree on your last point. Basically, I think I share that. I discovered very recently that I think Google X, they have this concept, they call it like compost. So project that didn't land or they had to be stopped actually before achieving anything. And I really like that they naming compost because it's still something very fertile, right? So you grow flowers, plants, fruits, food in compost, right? So even if it looks like what it looks like and it smells what it smells like, actually. I really like actually getting comfortable at killing project or failing in a certain sense is also something that I wish I knew actually to be comfortable with early on.
Yeah, I think at this point I can definitely think of projects and things that didn't work out, but actually the things that I learned from them made other things work. So it's that capacity to use it as a learning experience, both as a person, but also methodologically. So the stuff that you're doing. I have a question that I wanted actually to ask both of you, Usama and Alessia. And I guess it relates to some of the things that I'd said in some ways. So Usama, you went from company to company to sort of grow and to expose yourself to different things. And Alessia, you went through the training pipeline, I guess, where you moved from team to project. How did you find that as a learning experience? Because it can be daunting in its own way.
Sure, I can go first. It's definitely daunting because every time you join a new group and you're working on data, you need to build new relationships. And then with data, another key thing that is critical is you want to also have trust too. You're giving people data. You want to build at least a track record with them. So I would say that that isn't the only thing. The other thing that can be challenging at times is building business context, especially when you move from domain to domain and the domains don't have a lot of overlap. The good thing though is that the more you do it, you come up with a toolkit. You come up with a bunch of techniques that you can use to ramp up faster, number one. And then also number two, you also, and I think this is very important, you get comfortable with not knowing everything and asking questions. Early on in my career, that was something I kind of struggled with, is like, when is the right time to ask questions versus not, but I'm a lot more comfortable with it now. So overall, I would say that it's been challenging, but also very worthwhile. It's a great way to expose yourself to new problems, new ways of even dealing with the same issues company to company.
Yeah, I agree with what Ahmed said. And if I can add, it's a humbling experience, right? Because you find yourself, you left actually a previous project where you felt, I got it, right? So, and then you find yourself almost like starting from scratch, actually, and having to figure it all out. And so it's very humbling, but it's a good humbling experience, actually, because it makes you learn to keep learning in a sense, actually, because you never arrive, actually, and the field itself actually changes actually constantly, by a new technique, actually a new problem. And so by also you actually being in control on that change, at least actually you learn how to adapt actually to a changing field. And it's the best, I think it's the best exercise that you can actually give yourself. And also I agree with Ahmed, actually, like, so that phase where you need to ask questions, where you need to rely on other people, is excellent, but also it trains you actually in listening to other people, actually, right? So data science, if you want to add value, if you want to impact, you need to listen actually to your business, actually to your organization, in order to lend something that actually is useful and is used.
Thank you both. That really does reflect my experience, where at least I'm often sort of speaking to domain experts where I know nothing about their topic. So going in there saying, I will help you, but I know nothing about what you're doing or why you're doing it is a bit of a double-edged sword. So part of what Usama said of sort of building that trust, and what Alessia is saying of, building up that toolbox of learning to sort of know that you can learn and you can impact has been quite an important thing for me.
Great, thank you so much, everyone. I think before we go to Slido to answer questions, I just have one final question for you all, and it is, what advice would you give your younger self now that you're in your positions now today? What advice would you give yourself maybe 5-10 years ago? You're a student thinking about where my career is going to head. What advice would you give yourself? Don't all speak at once, it's okay.
I can start very simply: to worry less. Worry less, have more fun.
I agree.
Yeah, worry less in that also. I think also it links back to what Mohammed said. You think that before getting into any field, I think not just data science, you think that you need to master everything or as much as you can, especially data science, actually, where it seems actually you need to be so good at so many different things. And don't feel that don't wait until you feel ready in order to try to enter the field. That's what I would say, because you will never feel ready, actually, because it's not a field where you ever feel ready. I mean, I still suffer from imposter syndrome. I'm not sure whether Mohammed and Helen actually feel the same, but you never feel completely right, because it's such a complex and heterogeneous field that you'll never master everything. But it doesn't mean that you're not good at what you're doing.
Thank you, Alessia.
I can't agree with Alessia more. I'm just reading a paper yesterday where they're using concepts from quantum physics theories in order to describe directionality in graphs. I don't even know where to begin. So you will always feel that impulse. At least technically, there's always something new coming up. There's something changing. But I think the point is to be comfortable with that sort of dark space, and whereby you don't know anything, but you have a torch which allows you to look around and pick things up. For me, I think it would be the fail fast and grow from it. Things don't have to be perfect. Two, results don't need to look amazing. The important thing is to strike the iron while it's hot and to be able to know when to move from it. I think earlier on, much like what Alessia is saying, part of that, maybe that imposter syndrome, maybe that kind of looking up to your peers makes you think, okay, everything must be at some impossible standard that nobody can achieve. So don't try. It's okay to fail. Just do it fast and keep moving.
I love that. Thank you.
For me, I would say I agree with both of those things. The other thing I would add is being like an effective communicator. And by that, I mean learning how to write really well, especially now that we are working, a lot of us are working remotely. I think that's very important. It's a good way to actually like set yourself apart from the pack, especially in engineering, where there's a huge focus on coding and other technical skills. So that's something that I would really recommend, just working on your writing skills.
Great. Thank you, everyone, for that feedback. Really appreciate it. I know we have so many questions to go through now, so let me just stop my share. Let's go to Slido. Ooh, how do I move this? Great. Okay, so we have a lot of lovely questions. Where do we start? I'll probably start from the top with this question. So you guys can answer, whoever can answer this question. So are there any particular certifications that you would recommend for someone who wants to become a data engineer? I think probably this is for you, Usama.
No, there aren't any particular certifications that I would recommend. For someone who wants to be a data engineer, there's a couple of things that I would recommend. One is start with SQL, right? SQL is really, really important if you're going to be a data engineer, no matter what company you work at. You want to get a good handle on it, and there's a lot of online resources for that. The second thing is a language of your choice. Python is the most common language used in most data groups. So I would say pick up Python. You don't have to be an expert with Python. And quite frankly, you don't have to be an expert at anything. You just want to have a, you want to be familiar with it, basically. And so when you have your SQL and you have your Python down, the next thing that I would then recommend is to just look at tech blogs and understand how companies are using data. You want to be able to speak that language. What is data being used for? Those are the three things that I would recommend. And I will also say that I know it may sound easy, but it's really not that easy. And the reason is because it's overwhelming, because there's so many resources online. If you just go to YouTube right now and you type in SQL, there's 20 channels that are going to pop up. So how do you know which one to pick? So I want to acknowledge that. I know it's pretty hard to do self-directed learning, but I really do think that that's the best path forward, at least in my opinion.
Great, thank you so much. I think you also covered off what program language should someone be looking into data and machine learning. So that's Python, SQL. What else? Is there any other?
Can I add to that?
Yeah, go ahead.
I'd honestly say that you don't need any programming language specifically, just learning to program and learning to do that proficiently, because most of these things do exactly the same thing underneath. So, and the notion of programming is the process of taking a concept in your head and being able to express it in such a way that a machine can execute it. So as long as you can do that, you can always translate it. So if you're a C programmer or a JavaScript programmer and you're comfortable with that, it'll take you a couple of weeks to be able to do what you need to do in Python. So learn to program, in effect. Don't necessarily focus on just one thing, because these change from year to year.
Great, thank you. Okay, next question. What were your experiences with landing your first job within data and breaking into the industry? Maybe Alessia, I'll start with you. This question.
So I'm not sure how to interpret this question. So it was like my experience before landing that job. Or,
potentially, yeah.
Yeah, that's a good question. I think coming from research, so academia, so I knew that I wanted to work with data, and not just with data for the sake of it, actually, but to explore research questions in a setting that was not academia. And so I think the biggest challenge maybe there was actually translating my approach that was coming from this lone, academic research, actually working instead in a business context. I think this is something that sometimes is, so the focus also of the previous question was on the technical tools. These are the easiest things to pick in a certain sense, actually. Also, as Mohammed said, actually, once you learn, how to, like the mindset a bit of programming, actually, then you can pick them, programming languages, actually. Also, on the job, actually, these are just tools, actually, to try to structure problems and then, try to find solution to these problems. And so I would say the biggest challenge, I think, in my experience was actually change my mindset from, pure passion, actually, in learning new technique and actually playing with data, instead actually moving and think about, okay, I'm here actually to addressing a business problem, actually, and trying to find solutions. So that change was, I think, a bit of a shock to the system, actually, in my first experience of landing my first job in data. If that answers the question.
That answers it. Thank you. I think we've got a question from Fabio. He says, I'm a student in Python learning the language on myself with online courses. How long do you think I have to study to achieve a professional level? I think this is an interesting question, especially for students who potentially feel like there's a traditional way, a pathway to get into data science. I don't think there is, from what you guys have been telling me. But what would your advice be to Fabio?
If I can answer, explore. So there's many types of learning. And I think often one of the most effective types of learning is doing the thing that you want to be doing in the end. So if you're interested in data, once you learn what a loop is and how to read a file, then go out and start actually using that in order to solve problems. So join the sites that put up data sets for competitions, join the forums, start building things with it. Join communities. One of the most effective ways to learn is to learn from peers. And today we're in a fantastically, open world with respect to what it used to be before, where you can join, 100,000 different GitHub projects, which are all doing something with data, contribute. If you just start as writing the documentation even, but interacting with people and building things is the most effective way to learn once you have just the basics sorted.
Great. I think that is very comprehensive.
Could I add on something actually? I think we hear this question quite a lot about how long are we taking actually, and I think it depends on your background, right? So if you know another programming language, and it's easier actually to make that, to learn Python, for instance, if you really knew, I don't know, C++, actually, because as what Mohammed was saying, you already had actually the programmer, I think, mindset actually. So it really depends on your previous experience, but also I would say just try, right? So apply for jobs, and then let others decide that you're not ready. Actually, don't doubt yourself. I'm not ready yet. Actually, which is also what Ahmed was saying. Actually, that interviews every year, but also just to check actually where you are actually on landing your dream jobs or your next dream job. Actually, so.
Yeah, I would highly recommend you guys, if you are looking into getting into this field or just changing careers, interviewing every year and seeing what the market is out there, then that's always a good exercise to do. Thank you, Alessia. So next question from Abshir, we have... Go ahead.
I just wanted to tack on my 2 cents here. I would say that I would really recommend, and this is a response to another question about my experience breaking in, I would really recommend trying out projects, build projects, and then when you do 1, you do 2, you do 3, at some point, it's a great way to learn because it's practical and it gives you confidence that you're ready, right? As Alessia said, it's best to let other people decide if you're ready or not, but doing projects will give you that confidence before you take that step.
Yeah, thank you. We have a question from Abshir. He says, have you experienced wrong decisions made using the right data? I think it's an interesting question.
Yes.
Do you have an example?
I'm not sure I can talk about it. Let me step back a bit. This gets interesting because it's the point of, do you trust what you're inputting, and do you trust what you're evaluating? Suppose that let's take a dumb question. I'm interested in selling mortgages, and often early models that were built on these types of sort of questions ended up biasing against women. They would say that women earned less on average, therefore they were less likely to pay back the right amount. They were wrong. What they effectively did was they cut off a good, reliable segment of the market and made those companies that were using those models less profitable. A prosaic example, but fundamentally what lies underneath there are the assumptions that people make. That model to do this was chosen because a data set was input, and some criteria that someone came up with was used to decide whether what it produced was right or wrong. And that criteria wasn't questioned. Right? If people didn't say, hold on, what are the factors behind what this thing says good or bad, and how do we evaluate that? And often that's where things go wrong. We either tend to assume that what we're putting in is correct, or our judgment of what we should evaluate is correct, without questioning ourselves. And this is where I think the most important thing that's often neglected comes in, which is people and diversity in people and the capacity to value difference in people. If you have a room full of the same sort of generic copies of a person, people that come from the same background, that do the same thing, they work in the same way, they're most likely going to evaluate something in the same setting That's why you need diversity. That's why you need people that didn't study STEM subjects to come and work in data science. That's why you need people that come out of ethics and social sciences and literature and the arts to come into data science, because these decisions fundamentally impact on our lives. And we can't leave that sort of control of that impact just to the engineers and the business analysts.
No, 100%. I definitely agree. And for those individuals who, you know, are doing career changes, transitioning from areas to areas, you know, it seems like data science, data engineering is a good place to look into. So yeah, I appreciate that. Thank you.
Maybe mention a different interpretation of these questions. I mean, I agree with Mohammed. Actually, it's a beautiful answer that you gave. So I think, I'm not giving also precise example, but decision made without actually at the end looking at the data or the insight based on the data. Right? So, and this is something that if you work especially in analytics or when you work as a data science actually lead to, you know, insight decision are made. Sometimes the decision is not based, the end decision is not based on the data or just on the insight actually, because other factors come into play. That are not, you know, the insight derived from the data, and this is something you need to get comfortable with. So data and insight are not everything actually to create a decision. Even if you spend, you know, how long you spend actually producing those insights.
Great, thank you, Alessia. Okay, great. We've got a bunch of questions coming in, so I'm going to try and speed through these. So I'm just going to be picking through some questions, and then hopefully we're not answering the same questions over and over again. So I think this is an interesting question from Mahad, where he says, have you personally encountered biased data in any of your projects? If so, how did you handle it?
Yes. One of the main data sources if you work with online web analytics is user behaviors, and in Europe at least we have these things just called GDPR and some other legislation, so you need to ask for explicit consent to track users' behavior online, anonymously of course, but you still track user behavior online. So it means that some people actually say, no, I don't want you to have this data. And so you use the data of those who consent, and the user who consent may not actually be a good representation of all the users on a website. And this is where you base your analytics and all your decisions. So this is actually the example of possibly biased data. What do? You caveat your analytics and findings. So you just make explicit these results, these output may not be representative of all the users of this site.
Great.
If I can add to that, so there are many different ways in which bias comes in, right? What Alessia has talked about is, you know, bias out of consent. I don't want to be in the set. Yeah, there's also bias in how we gather data. So if I take an example in healthcare data, people that look like me and even further, you know, young, Black women like Miriam are highly underrepresented, which means that when medical analysis is done, when drugs are developed, when symptoms are analyzed for, they're not going to have data that actually matches you. Yeah. So that means that those remedies that are developed aren't necessarily going to be effective for you. Yeah, and that comes from how we gather data and what we look at. If we go back, 15, 20 years ago, nobody really paid so much attention to that. Yeah, and people still probably wouldn't be paying attention to it if noise wasn't. As well as sort of the opt-out sort of clauses. There's a lot of issues with how we generate data, and the fact that often, as Alessia said, people don't put either a remark on the analysis to say this is what this applies to, or the other direction, which is go out of their way to fix the biases in the data, which they often need to.
Yeah, totally. Thank you. Okay, just for everyone who is using Slido, if you want to get one of these questions to be popular and for the panelists to answer, please vote by pressing a thumbs up on the question, and that's how we'll be asking these questions. So the next question is from A. Omar, and he asks, what does machine learning look like in the future, in 2 years' time, and potentially in 10 years' time? What's your vision of this? What will it look like?
Mohammed, you go. On the spot.
I had a feeling you were going to pick on me. I don't know. So there's lots of very interesting things happening. Let me step back from the hype and let me tell you a little bit about problems with machine learning. Machine learning can't generalize. We don't know algorithms that know how to learn to learn. When they do know how to learn, they do it in a very limited sort of setting. They're really complicated. They're exceptionally energy hungry. So there was an analysis done recently on one of these, latest and greatest language models with hundreds of billions of parameters, and the energy cost to build that model, was equivalent to the lifetimes of several, I can't remember the number, tens of cars over their lifetime, from manufacture to being disposed of, or someone else calculated it was equivalent to sending a rocket from the ground to the moon. Now, the complexity in sort of building these things shuts out a huge number of participants. If you want to build the current state-of-the-art vision, language, speech type of models, you need the supercomputers that Google and Microsoft and so forth sit on. The data sets that they look at are predominantly about the global north. Take language, take vision, take speech. They don't consider the images or the speeches or the texts or the languages of large majorities of the world. What I hope is that we start to tackle these things. We start to make these things useful. We start to make them less, carbon hoses for the environment, and be more representative and serve more people better.
Definitely. Thank you. Thank you so much. I think, Usama, we have a question for you. Can you give us examples of the business questions you would ask when looking at data?
This really depends on the data that my apologies about the siren in the background, if you can hear it. But this really depends on the data that you're looking at and the types of questions that you're looking to ask. So for example, you may be looking to understand how engaged your users are, right? Or you may be looking to understand how fast your business is growing, right? So there's a lot of different types of questions you can ask. One simple example could be, if you have launched a new feature on your product, you might be interested in knowing how well those users are retaining. So for every user who tries the feature, are they coming back or not? And then if you find out that only 5% of them are coming back, that might be a sign that the feature either needs work or you might just need to shut it down. So that's the type of thinking and questions that you can kind of tackle if you have the right data.
Okay, great. I think we have time to answer one more question. So guys, I'll give you a few minutes to vote on one of your popular questions before we end on this final question. I'll give you a few minutes to vote, and then
I think we can quickly answer the one about certifications in AI as well as I think that certification is not going to harm anyone. So yes, if you have the money to spend actually on, I don't know how expensive they are, but yeah, they don't harm and they are recognized.
Great, thank you. Okay, I think people are voting. Hopefully they are. Give you a few more seconds. Give you a chance to get one of your popular questions on the top. 5, 4, 3, 2, 1. Okay. So I think this top question is very general, and I think we covered that really well. So I'm going to skip that question. So I think I'm just going to go to, oh, this is a hard one. think I'll go with a question from Suleiman, where he says, which would be better when someone wants to pivot into data engineering, learn cloud platforms like Azure or AWS, or focus more on Python and SQL? What would be better? I think that's the question.
So I'm biased here because my path into data engineering was focusing on Python and SQL. And my experience with interviewing at companies that are looking for data engineers is that they care about the fundamentals. So you'll be asked more about Python and SQL versus cloud platforms. I think the one exception there is if you are interviewing specifically with Amazon or Google, right, or Microsoft, then in that case, I can see how as a data engineer, they'd expect you to understand or know their platforms. Personally, my take on this would be, I would say you want to, either of these approaches are good, right? You really just want to pick something and commit to it and not flip flop between the two.
If I can add to that,
Sure.
there's something subtle in here, which is platforms are effectively about DevOps, so development operations. If you were to have an expertise in Azure and AWS, I'd expect you to be able to understand how to use those platforms in order to make development easier for the engineers that we're putting something onto those. Whereas if you were focused on Python and SQL, I'd expect you to be developing these things regardless of the platform that they run on. So it's a question of what are you interested in? Are you interested in building the stuff? Or are you interested in building the infrastructure for others to build the stuff on?
Absolutely. Thank you. Thank you so much, everyone, for answering these questions. I know we have still 15 questions to answer, so I think we'll take this as an opportunity to answer these offline and share with the community directly in Slack. So that's what we'll do. We will do. So let me just go back. So guys, thank you so much for this. I think this seems like a great point to wrap up. Thank you to all our speakers and all of you who attended today. Hopefully you enjoyed today's event and will join us again in the future. If you'd like to keep up to date with all things Somali and tech, then join our growing community. In addition to panels like these we host, we will be hosting exclusive workshops, socials, and I know you guys want an in-person one, so hopefully we'll do that soon. We would also love to hear your feedback and thoughts on this evening's event. So we would like to kindly invite you to fill out our feedback form so that we can continue to deliver these great events. All our speakers are on the Slack channel, so please join, reach out to them. And like I said previously, your network is your net worth. So please make use of everyone, reach out to us, speak to everyone, connect on LinkedIn. I think that's the only way, best way, I think, in my opinion, to really advance your career and go forward in tech. So on that note, I'd like to say thank you and goodbye, and please fill out our feedback form.